Hello everyone, welcome to this particular session. In this particular session, we are going to discuss about how sentiment analysis can be modeled using various traditional machine learning algorithms. So before we start, let's see what we mean by sentiment analysis. Sentiment analysis is a typical operation in the NLP in which we can develop a model which can analyze uh, the opinion of the user about some brands or service, or it might be a political champion. So most of the time, the firms or organization or the political governors want to see what the followers of the followers or their followers or the user of their user or their customer, what what do people say about their services or uh, the service or about their brands. If it is business, they want to see how people look about the service. That regards is very popular application in the NLP. Today, let's see how it works and how we can develop a model using the traditional machine learning algorithm. There are many traditional machine learning algorithms, including logistic regression, subvector machine, random forest classifiers, decision tree classifiers, k-neighbor classifiers, multinomial neighbors, and so on and so far. So let's see the practical example. So first we import the pandas library. This is used to this is just data manipulation libraries. It's used to convert any data to the rows and column ways. Second, we import the library dataset, load datasets from datasets, and these files. Then actually this we are taking converting this data into the data frame. Actually, the train data sets into the data frame. Then just we organize it. We trim those. It may have various columns, but we trim only the important columns, which are the text and the level. This regards the rest of the validation and the sets, and we should later. So then we come to the algorithm parts, where we just import train test speeds from the model selection. We import logic regression from linear model. We import support group from module, support vector classifier from support vector machine. One by one, this all are traditional machine learning, because this is scikit-learn. This is a built-in package. From package, from package there is a module. For module, we have classes, so we import these classes from module from package. Then at last, we again split the dependent variables and independent variables. This is independent variables text, which determines the y variables. Y variables are labeled variables. So in this y variables, based on the x variables, it can be positive, negative, or neutral. So finally, then we have extreme white, extreme white. We split the data to time and valid. Then next we convert the raw text data into the numeric vectorization, because machine algorithm only understands or it's only receives numeric data. So we convert the raw text data into the numeric vectorization in order to machine understand easily. Here, so let's say vectorizer is variable name. So the def is kind of text feature extracting method of this why. So we convert it to numeric vectorization, then we force it into the extrain white line. Then this is also converted to the excess data. Then here we check whether the data is empty or not. Finally, we train the model was what is about the classifier here. The model not fit, then it's trained. Here is training. We train it. This actually is supervised machine learning, so supervised machine learning for each independent variable there is allowing dependent variables, like giving we teach our children what they to do and what they not to do, like that. So here we are giving something x. This x is positive. This is positive. This is negative. This is neutral. So we teach our model. So based on this this labeled input and outputs, in or later when we give unlabeled data, it can classify based on what is labeled. So here we train it. Then finally we are going to evaluate an evaluation. There are metrics, different metrics. F1 score, accuracy, F1 accuracy scores, precision, and the records are there. In case of then we have predictions, the model predicts predicts about the test data, unseen data. So based on the unseen data and finally the matrices we approximate to the 4 digits. This floating point, 4-digit floating points. Then finally it gives us the results. This is all about